So hello everyone. My name is David Selph. I'm from JPMorgan Chase in the digital organization there, and I run a team of digital team that looks after digital intelligence. So we run intelligent bots to kind of do the quality assurance for a lot of Chase's products. So today I'm going to talk about how we're approaching this in an increasingly complex environment in terms of our applications have become incredibly sophisticated. They do all kinds of machine learning behind the scenes. They do all kinds of personalization behind the scenes. And we have thousands of developers that are improving this stuff every day. That makes it really difficult to kind of assert things, right? Because things are not deterministic. So based on the customer profile or based on the application time of day, or sometimes we have things like weather patterns that influence functionality. Because at one point we were experimenting with, save for a rainy day. The assertions are really difficult to make and they're non-deterministic. So we've adapted based on those challenges to meet those challenges and kind of still try to get an excellent product out the door that we understand it works really well for our customers. But we've had to implement some pretty sophisticated features to really do that. On top of that, it makes it really difficult to validate all this stuff because the customers use their endpoints, their devices, their browsers in many different ways, with many different bandwidths, with many different conditions around how they're using them. We have to test in a lot of different form factors, a lot of different devices, with a lot of different conditions that exist. So each test might run many, many times under different conditions. And what that generates is just a massive amount of data. So we collect all that data and we try to tie it all together, and that's really what this visualization on the right is all about. Because we store a lot of that stuff in a graph database. So we store it in a Janus graph database inside of Cassandra, and we link together all of the information related to a particular scenario to really understand it deeply and figure out what's going on there. So today we're not really going to talk about making a specific component work. To make Chase apps work, we probably have a few hundred different individual components that make the overall Chase apps work well. And a lot of that is around unit testing and getting your coverage up and all of that kind of stuff. So that's a topic for another day. But today what we're going to talk about is once you've established that those components are working well, how do we make sure that they're all working well together? So kind of the end-to-end testing. How do we make sure that they work well with all the different business data and account types that exist out there? So we have 20 to 30 different account types. So all of those account types can be combined in different combinations and can create different profiles. And again, similar to the endpoint situation, it causes a massive amount of variation that can occur. We have different branding and different customer segments. So how do we validate across those different things on top of those other things? And then, this overall is pretty complex. But what's really important is that we don't miss anything. And that's what we're going to talk about today, is how we try to make sure that we don't miss anything as we're doing this validation with, somewhat infinite possibilities of different combinations that could exist. So to do this well, we really have to understand our application's behavior in detail and focus on what's normal. So this presentation is really a lot about what's normal, what's not normal, and what's changed. So that's what we're going to focus in on. Just to be clear, the fundamentals, there's still fundamentals that exist, which is, 1 plus 1 still needs to equal 2. So there's a lot of fundamentals that remain, which is just the traditional, if I add $1 to a bank account, make sure that the bank account has $1 more. Like that stuff, you can't really get around because those are the super important things. But the techniques we're going to use are to really make sure the overall customer experience doesn't regress. So Chase and its products, we have thousands and thousands of screens. But in order to solve this really complex problem, you can really break everything down into like what profile a screen has, what services does that screen depend on, what UI components does that screen have, and what are the possible actions for that screen. So if you think about it in those terms, you can take a very complex problem and kind of break it down into its parts, and that's what we're going to talk about today. So it all starts with the customer behaviors. So if you really think about the process of a QA person sitting there trying to figure out how the customer is going to use the product or in what sequence the customer is going to use the product, it seems a little bit silly when you have millions and millions of customers, because you have that data and you have access to that data for anything that's already in the wild. So you can harvest that data and use that data and find out what customers are actually doing and the journeys the customers are actually on to make sure that your application is not regressing as you add new features to that application. So we don't try to predict customer journeys. We harvest the customer journeys and map these out into screen usage and flows. Now, I can't show you the actual data because I think that's somewhat proprietary to Chase, but this is kind of a visualization of some of the actual data that we get out of our systems, which shows you that there's basic user journeys that are used really heavily. And it tends to be kind of the log on, review your dashboard, look at your account activity, and that exceeds other user journeys by far. So you can pretty much say that that's a really important user journey. But then it kind of goes down, and you get the less used user journeys down here. And those, in our opinion, are equally important. But there's a lot of debate about that in terms of, do you really focus on your core journeys or do you focus on your least used journeys? Because the core journeys, you'll know pretty quickly whether those stop working because everybody's using them, whereas the least used journeys really become important for kind of the synthetic monitoring because they're not always used. You want to make sure that when they do get used, the experience is great. So based on all of this data, I think we can really pull these visualizations, and it hasn't always been easy because, if you look at the way most behavioral analytics systems are set up, they're set up for the data scientists, they're set up for the marketing folks, they're set up for the product folks. So when we came in and kind of said, look, we want to harvest this data for quality, we did have to change some things and kind of get some connections working that weren't there before. But it absolutely makes sense, and I would encourage everybody to kind of do it. But what this allows us to do now is it allows us to baseline our application behavior to what we call kind of blueprints. So we can kind of have user journey blueprints, we can have screen blueprints, we can have services blueprints. We can have all of these blueprints that tell us what's normal in the application. It also allows us to understand, where people are spending a lot of their time, what things are being heavily used, and what things are not being heavily used. And the last thing is it allows us to visualize our failures. So we can really see, like, if, for example, if you went through one of these user journeys, and let's just say the open an account page was having issues, you would be able to see that all of your testing would kind of stop there. Like all of this testing over here would be red, and you would really be able to visualize, like, hey, that's where I can pinpoint the failure. And we'll talk about more about that a little bit later as well. What that brings us to is, a lot of these journeys happen based on a profile. So you can think of a profile as unlocking features of our applications. So whether you're a retail person with retail features, or whether you're a business person with business features, like that's how we determine what features get unlocked for you. And what we found is that really 60 to 70% of the user scenarios or the user journeys that we want to test can be unlocked with pretty generic user profiles. So we do use a lot of the intelligence from production to gather intelligence around what types of profiles we should create. And we create things that we call personas. So these personas are very strict profiles that have that all look the same. So one of the key things here was that these don't change from when you go from environment to environment, or even when you go from user to user in the same environment. These things cannot change. They all need to be identical. And we didn't start out that way. We started out with like a minimum set of attributes, but we've evolved to say that these all need to be identical. And to get them to be identical, we use something called contracts. And contracts is just a listing of of what needs to be true for those users. So they need to have a checking account, a savings account, a money market account, something like that, and then what types of products they're enrolled in and what user segment they're a part of. And once we define that in kind of a machine-readable format. We maintain these databases of users that all look the same. And we go through a lot of operational processes, which most of it's automated, and we're always getting closer to fully automating the process every day, but to maintain these users. So it doesn't matter whether you're in development or integration or QA or staging or production, you're going to get the same user. It might not be the same exact user, but you're going to get a user with similar attributes. So now we're able to go through these environments with a lot of stability and a lot of reliability and get through our SDLC very efficiently without having to worry about data. And to put that into perspective, we used to have probably about a third of our tests just failing because of data. Now, it might have worked in development, but then when it got to the integration user, it stopped working, or maybe it used to work in integration and somebody corrupted that user. So this really solves a lot of those problems and really allows us to get through the pipeline very efficiently. It also allows us to replay these user journeys in an efficient way because we know what types of user journeys we're looking for when we have a particular persona, and we can match those things together. So don't want to say there's ghosts at JPMorgan Chase. There definitely aren't, but I think getting to this stage, we kind of discovered that users will just, change for unknown reasons, and those reasons, if you dig into it, you can figure it out. It could be because there's an outage, or it could be because a manual user kind of took that user and did something with it. It could be for a number of different reasons, but it happens, and it happens more often than you would think it should happen. So what we do here is we kind of maintain these pools of users. We track which users are being used because obviously if two different bots are using the same user, you could conflict. One person could be adding something, another person could be subtracting something, and it could cause conflict. So we kind of lock these users out and say, okay, they're in use by a particular bot at a particular time. We constantly track the contract and make sure that these users adhere to those contracts. And we'll mark them as, we'll quarantine them, and then there's an auto-provisioning process where we'll go out and we'll try to fix those users and put them back into rotation. So we have processes that are constantly monitoring what's being used, what's not being used, what's adhering to the contract, what's not adhering to the contract, and what's available, so that we can throttle our test executions based on the profiles that are available. If they're not available, then obviously we have to throttle back and slow down our executions. Which then leads us to ultimately what we're trying to do is replay those user journeys that we talked about in step number one. So we want to replay these journeys. We want to have a good profile from which we can replay these journeys. So we want to mimic the customer behavior as much as possible. But in order to do that, we've kind of found that you need to have kind of intelligent bots that know a lot about Chase and know a lot about banking in order to do this well. So we've built our bots not to be generic, so we couldn't necessarily open source our bots to the world because they're Chase bots. They know Chase, they know how Chase works, and that's what they're best at. I'm not sure they would be that useful to other people. And we leverage a lot of open source products to kind of make these bots. So we are using and supporting the open source community to kind of create these bots, but the bots themselves are designed to be Chase bots. They're designed to know our applications well and work well with our applications. And to give you an example, I mean, you could say there's like everybody has their login process, but our bots are really good at logging into Chase products. They know how to get the credentials. They know how to do the one-time passwords. They know how to do all kinds of things when it comes to login or password resets or those kinds of things. And you can take that one step further to say, they know how to recognize accounts. They know how they know all the different account attributes that exist. So when we try to replay these things, we have to use bots that are really good at kind of banking features, and that's how we build a lot of our automation as well. That we build it in like modularized kind of components that are good at particular things, similar to how humans are good at certain things. You kind of come into a new job, you don't really know how things work, you look to your left, you look to your right, you kind of ask people how it works, and eventually you gain that knowledge. We aim to teach our bots how to do these banking features in a similar kind of way. So what we end up with is kind of a bunch of steps that we have to replay, but it's impossible to get to an exact reproduction of what our customer journeys are actually doing or what the customer journeys are saying, because of a lot of the intelligence that's built into our apps or a lot of the features that are built into our apps. It's rare you will get the same experience twice. So you can think of these red lines as, the bot replay, and maybe the gray lines as the user journey. Or you could flip it around and say the gray lines are the bot experience and the red lines are the user journey, because that kind of illustrates the point that it's not going to be the same every time. So things that can be different would be non-deterministic events like surveys. Surveys might get triggered 1 out of every 100 logins or something, so it's hard to tell whether your particular login will get that survey or not. It could be push notifications. It could just be, it's been X number of days since you've updated your profile or something, and the application wants you to update your profile. Again, really hard to track that kind of stuff because there's thousands of attributes that could influence those kinds of things. Or it could be really profile specific. So some users, may not have any recipients for bill pay or quick pay, in which case their screen will have a slightly different view than if somebody who has hundreds of recipients or bill pay vendors. So those kinds of things could be different. Like you could be looking for a specific account type and you may need the mask for those account types. Things like that is where we'll go back and we'll look at the profile to try to figure out, how to do those things. So in one environment, you could have had 256 as your mask. In the next environment, it could be 526. But the bots will figure that out based on the profile. And because they're good at Chase products, they kind of know what they're doing and they do that pretty efficiently. So we don't worry too much about being precise, because if you were super precise, none of your tests would ever run, because all of these points here would be different than what you might have expected. So we worry more about getting the test to run effectively. So we do look for signs of bad behavior and things like that, but we worry less about these things that happen that we know will happen, and we know that they're not really going to derail our test. So our goal is to get through the test. Now with time, we've kind of figured out that this is actually an advantage, because if you think of testing a survey or an MFA or something like that, these things are hard to set up and hard to get so that they happen when you want them to happen. But because we run so many bots and so many different user journeys, we've discovered that when they do happen, you can kind of use that as an opportunity. So we're starting to experiment with, when these events happen, we will abandon that test and we will start a new test, because we have like a golden ticket for an event that's hard to reproduce, and we'll validate that the behavior of that event is what it should be. So really, we've taken this kind of very difficult pattern and tried to make it so that it's working to our advantage, and we can leverage these hard to create events when they do occur. That generates a lot of information. Like we've gone through why it's important we have intelligence. We've gone through how we gather the journeys, because if we had to write thousands and thousands of test scenarios, that would take a long time and it'd probably be very error prone. We've gone through how we make sure the data is good and we can run those tests mimicking specific profiles. And then we've gone through how we kind of mimic those user journeys with the bots being intelligent so that they can get through the test scenarios. All of that information, those messages that gather a bunch of information about the apps as they're going through these user journeys, generates a huge amount of information. And that was the visualization we saw on the first slide. How that's broken down is we try to figure out what's normal, like what's normal behavior, what's the expected behavior, not by specifying it in a file, but by simply comparing it with previous versions of the application. So we have a bunch of sensors that don't worry as much about what should be, but worry about what is. So that their whole job is to figure out what is, and then the intelligence behind the scenes will compare the what is to the what was, and we use that to gain the insights that we need to really make our applications great. So it's broken down into, each app can have an app version. It can be different branches of that version. So we could be getting ready to release it. So it could have a stable version and a beta version. And then we also want to know whether the app is healthy. So we want to know if the app is ready to be tested. And I think that's a step that many people kind of skip. But the step to actually make sure the app is even ready to go through this process, we've found is critical to succeeding. The second set of data we have is like what devices and what endpoints are our customers using, and what steps do we need to go through to get a proper certification that the majority of our customers will have a good experience with that feature on those devices. The other thing is if you have a few hundred tests, it's really easy to run it locally or use a Gherkin report or get the visualizations you need that way. But when we have hundreds of thousands of tests, it's really hard to keep track of all these different tests and how they're running. So we have a whole database dedicated towards just tracking the tests. We track like the test IDs, so every test has a unique ID. We track the test health to make sure that it has a track record. So similar to humans meeting a stranger on the street, you don't really trust that person until you get to know them a little bit better. We don't trust our tests either until they've shown have a track record of performance. So if they can't show a repeated track record of performance, we will treat them differently than if they've performed great over a long period of time. We categorize all of our tests into which features they're testing, so we can report accurately to senior management and to the product folks on how we're doing. And lastly, we try to figure out how often to run these things and when to run them. And that's super important. And that gets back to making sure that we go through a logical process of certifying all these different variations. You then get to the screen, and the screen is a similar thing. So like I talked about before, we really break it down to the screen, and the screen is where the majority of the validations happen. So we have screen health, like the user journeys that touch that screen, the actionable elements on that screen, how much coverage we have on that screen, the screen views. So the piece I talked about before, where if you have no transactions on a screen or if you have a lot of transactions on the screen, the views kind of change differently. We have baselines that we do a lot of the visual comparisons against. So that's kind of the feature that Alyssa was describing earlier, where you really want to make sure that your UX and your customer experience doesn't change. Kind of map out how all the pages are interconnected, and then all the dependencies for content and media kind of go into that space. The service inventory is very similar. So we do a lot of the things there. I mean, the one thing that's different is we have a dependency tree, so we try to track all the services and what services they depend on. So we build out that whole tree so we can see where those failures happen. And then lastly, the user profile, where we really track, where are these user profiles located, because we have a lot of different regions that we can validate things on, and how do we access those through password vaults and things like that. And a lot of the auto-provisioning happens there as well, so when things need to be fixed, we go off and fix them. All of these things, they generate, they all have canaries. So they all have canaries that are sitting there constantly monitoring everything. So if something goes down, we'll instantly kind of know about it, and it'll start to notify everybody that depends on those things as to the failure there. We call those horizontal outages. So as an example, if a particular service stops responding or gets a 504, we'll be able to go through and say all of these tests could be impacted by this service not working. That's kind of the job of the canary. So we track each one of these things as they go bad. And that brings us to, just the sheer scale. So if you think about, all of this makes sense if you take one user journey and a handful of screens and a user profile, it all kind of makes sense. But when you do this, 500,000 times a day, the data can become overwhelming. So how do you, first of all, do that across all those different things? We've made our bots to be agnostic based on the product or the channel or the device or the viewport. So we can adapt whether it's on a mobile phone or whether it's on a tablet or whether it's on a laptop or a desktop. We can adapt to the different visualizations that happen because of the breakpoints and the reactive UIs and things like that. We adapt to all of that stuff. We adapt, with a lot of help from Sauce on, interacting with all these different devices and things like that. And then you have all the other stuff we spoke about as well in terms of profiles and everything else. Needless to say, these tests get executed a lot. They get executed in a lot of different ways. And to be able to make sense of those things is, we had a lot of challenges in doing that. So we've built a lot of visualizations and dependency trees to really get these things certified in the right order. So it doesn't make sense to jump straight to a physical mobile device if it's not working in just a web browser or a mobile browser. So we kind of go through a logical tree where we'll go through the large form factor, and then if large form factor works, we'll do the medium form factor and the small form factor, and then we'll hop from emulators to physical devices, and we'll go through all of these things basically based on the importance of it working. So we get the edge cases eventually, but we really focus on making sure the mainstream functionality is working first before we bother to run some of the edge cases or some of the less used devices. And that's how we get these visualizations. So you can see here based on these heat maps that you can start to really pinpoint where the problems are. Like you might say, okay, this thing is having problems on Chrome large versus this thing down here, which might be on a mobile browser or something else. And then we have here an aggregation of all the what we call certifications, and the certifications kind of tell you by channel how you're doing. So you can see, hey, those features are working well, or those features are not working well. They're working in all of our channels, or they're not working in a particular channel, and it helps you kind of get the confidence you need to eventually release your software. So all of that information kind of gets put into our database, and Alyssa has described a lot of this stuff around the actionable insights as well. But the actionable insights are really the only thing that matters. I mean, everything up till slide 5 is kind of leading up to this point, because we've had a lot of data for some time, but without knowing exactly what to do with that data or how to interpret that data, it's not that useful. And that's where the machine intelligence comes in. So we build the baselines, and then we're constantly comparing against those baselines to try to draw insights as to what we need to do. So we can figure out, was it something on the screen that changed? And if it's something on the screen that changed, maybe we'll use computer vision to kind of detect that. Or if it's a particular service that started failing, we can pinpoint that in one of these trees here, and we can say, one of these dots might turn red, and we could say anything downstream from there probably doesn't matter, because that's the failure point. And we build these blueprints and fingerprints that kind of detect all of these failure patterns, and then we label those failure patterns. So it might take us a couple hours to really understand what the root cause of some of these things might be. But once we've established that pattern, and then we understand the root cause of that pattern, we can apply a label back to that pattern to say, hey, next time you see that, you can kind of provide more intelligence around what the error condition was there. Or we might actually go and write some Splunk queries or some other type of queries that facilitate the validation of that error condition. So we use the machine learning to cluster and cluster all of these things and detect the patterns, and then some human intervention is needed to really label these things and give them names so they're human understandable and have actionable insights. But based on those root causes, there'll be specific actions that need to be taken off of the back of those failures. So just going through this screen a little bit, I mean, you can see here that we kind of have the developer experience where we're preparing the developer for, are they ready to do their PR? And this is a lot of a mocked kind of environment where we give them a lot of feedback just in their sandbox without a lot of downstream dependencies. We have kind of the user data that we talked about, which is super important, and where it's green and where it's not green. So if it's not green, then you might consider that you don't really want to rely on the tests too much because you're not getting good data. But if it's green, you can rely on those tests, and we track like how many user profiles and how many logins are working up to 100%. We expect 98% or better to really be reliable, and those are those deep greens you see there. Anything less, it starts to turn more yellowish. And then the reds, or some of the reds there are either things that are not in use or things that we're looking to deprecate, or maybe they're just really hard profiles to create, and we just haven't created them yet. And then if you go over here, you can kind of see, I spoke about this a little bit earlier, but this is a statistical algorithm that we use to try to determine if the tests are actually working or not working. We place very little value on a single test working, and very little value on a single test not working. So we kind of build these trends that detect whether we should care when something doesn't necessarily work. And you can see here that this gray dot here was something happened in the navigation of the browser. We weren't able to get from one page to the next to the navigation processes that we have. So that's probably an immaterial error, right? It's probably a blip, and maybe our security systems, or maybe the network latency or something happened there that caused that to fail. So we don't put a lot of value on it. We just kind of turn it gray and say, okay, that happened. But if we had seen like a series of those, or if they were intermittent, we would place a lot more value on those failures. And that's naturally what humans do anyway. So that's what we used to do when we would just look at the testing. Before we had a lot of this intelligence, we would go in and we would say, okay, is the test passing, or is the test generally passing or generally failing? And if we saw a red, green, red, green, red, green, red, green, we would say that test is flaky. I can't really rely on it. The red doesn't mean much. And these algorithms kind of try to mimic a lot of those decisioning processes as well, and try to give us a lot more information. So we also have, you can't really see it here, but a blue. The blue means we just don't have enough evidence to call it one way or another. So we didn't execute it enough times, or didn't execute it all, and that's how we there's other bots that go around and try to figure out where the blues are, and they'll start executing those scenarios. And then if you go over here, we build these complex graphs that kind of determine all these different relationships, so that we can use that information to do the horizontal outages as well. So we can detect who's going to be impacted by particular failures when they happen, and kind of notify them that something's happening. So really, it's each one of these things is pretty simple in itself, but putting them all together makes it incredibly powerful, and allows us to run hundreds of thousands of tests and actually make sense of the results all the time. So that's how we're able to get all these variations and get all these user journeys certified as part of our release process. So to wrap it all up, I think if you've been following along, and hopefully it's been clear, the benefits we've really, like, the results are at the end of the day what most businesses care about, is getting the results. And what we've found is that by doing all of this, and it took us a couple of years to do it, but by doing all of this, we're really able to reduce the maintenance down to something tangible for the number of tests we're running. So the maintenance burden has always been the number one barrier to really getting a lot of coverage, because if you really think about automation, it's a little bit counterintuitive. So you have 3,000 people changing your system on a daily basis, or 500 people or 200 people. Like, these people are changing your systems every day, and you're expecting your tests to kind of just continue to work over and over again. you're going to have to edit and maintain your tests as you're making those changes, and that maintenance burden can be quite high because it's a moving target. So through that, I think we want our developers really focused on maintaining the tests for the things that have changed, but we can make sure that the regression kind of always is self-maintained based on the changing behaviors of the users as they go through. So we don't have to do a lot of the legacy maintenance. It's just the new stuff we can focus on, and that's how we really reduce the maintenance aspect. Secondly, the cost is reduced. So as we've made a lot of this stuff autonomous, it's allowed a lot of our staff to focus on other things. So the bots will validate the user journeys, and the humans can focus on the human perspective and the human experience that the apps come with, which the bots are really terrible at doing. Because if a page is weird loading or something else happens, the bot's not going to detect that. It'll detect that it didn't load properly, but it's not going to detect that there was a flicker that happened as it was loading or something, or the transitions weren't smooth or something like that. The third thing is the speed to market. So obviously, we used to be on a much slower kind of release schedule where you would go through your QA cycles and do all of that rigor before you did releases. But we're really starting to release much more frequently now. So we don't have the time to wait for people to go through all of that rigor and kind of do that stuff. With the bots, we've been able to really increase that. So in a typical very large deployment, we can certify a big chunk of our Chase apps in about 20, 25 minutes. And that's huge. I mean, that was a great milestone to achieve. And the last thing is just, with Sauce's help, we're able to do this at a massive scale. So we generally run about 5,000 bots at a time, maybe. And through all of these processes, we're able to do that at a tremendous concurrency. And that's how we achieve, the 25-minute milestone as well. So overall, I think the strategy is working. I would encourage you all to kind of think about these things and take the bits that you like and experiment with them, because the results are actually quite good. So with that, I think we'll take questions.
Thank you, David, so much. Really appreciate that. And that was a great presentation. I know that there are some questions both in the Slack as well as within the Zoom chat. Maybe what I can do is I could feed some to you, and then you could also look at the Zoom chat as well and see if there's ones you spot there that I may have missed.
Sure.
So the first question that came from the audience was, it looks like, I mean, it's a tremendously elegant solution to a very difficult problem, and there's a lot of moving parts within that. What types of tools, specifically on the open source side or even homegrown, did you use throughout the development of this solution?
That's a great question. So I think we have a multi-tiered approach. So we kind of take whatever's available on the open source market, or even vendor solutions. We'll take whatever's the best out there, and we'll try to reuse that as our first point to get some of this stuff done. So as an example, we use Selenium and Appium and those, and Cucumber and all those kinds of tools to do a lot of this stuff. So that's probably 70% of the solutioning. It's just going out and finding the right tools in the environment. Once we've done that, we'll go and we'll look internal to Chase. Chase is a very large organization. We have a lot of tech talent, and there's a lot of people that have built really amazing things inside of Chase. So if we can't find what we're looking for in kind of the broader open source market or the vendor community, we'll go internally and we'll see who's innovated or who's kind of developed something similar that we're looking for. We'll partner with that organization to kind of bring that in and integrate that into our product. And then really where we focus our time is on the last mile aspect of the automation. So we want to say these bots are Chase bots, like that's where we focus a lot of our time in really building things that are specific to our domain. So we have no desire to really build things that are not specific to our domain, because in the spirit of the open source community and things, and we have contributed on occasion to some of those things, we will contribute back to those things when it makes sense. So there's no point in kind of building our own proprietary thing that's not specific to us. And that's where we spend a lot of our time. So maybe 20% is in that space there. So a lot of our development and a lot of our work is centered around integrating these products and making sure the information flows are high quality. So start by, and we use Kafka streams, Elasticsearch and Cassandra to kind of get all this data down. But and then we use Flink for a lot of the real-time processing of the data and the intelligence behind some of this stuff. So getting those data streams clean and getting those data streams high quality is really the first step in the process. Because if you don't have those high quality data streams, it's really hard to do the rest. Then you would focus on the Flink processing and making sure that you use those data streams to garner intelligence and to baseline your patterns. And then the last step is you take those baselines and those patterns and you try to get your intelligence out of them through, we use a lot of Python to do that. We have like proprietary machine learning technology that runs on AWS and other things that was built for the bank, not specifically for us. So we'll run our models on those types of technologies to garner the intelligence out of that data. Make sense?
Great. It does, definitely. Thank you for that. We've got time for maybe just one more quick question, and I'm going to be selfish, and I'm going to take it for myself. If there are other questions, though, please go ahead and post them in the Zoom chat or certainly within the Slack channel as well. And there are links within the Zoom chat to the Slack channel. So if you have problems there, I'll go ahead and do that. My question kind of goes back actually to one of the first slides that you had when you were talking about the persona. So many times when I'm talking to customers, they're focused on obviously the use case and making sure that either the functionality works properly, or that again it's performance or it's visually sound, those types of things. My question ultimately comes down to how much of that persona building are you doing yourself versus involving product owners, whether it's the business owners themselves, the designers. How much of that thought and exercise goes into at the very, very beginning, and then how does that manifest throughout the rest of your cycle that you just talked about?
Yeah, that's another great question. So I think or the way we look at it is we have the aspirational personas, which are developed by the product folks, and those are the personas that we would either like to have or that we think we have. And then once you get to data as to the real customer base out there, you kind of get the actual personas that exist. And there's a constant loop that's going on. I mean, as we develop our products to be better and better, so do the people that run the Chase products. They develop their products to be better and better. But we're constantly kind of comparing those two. So we take the products, aspirational personas is what they think they have or what they would like to have, and we're constantly comparing that against to what actually exists. And we're big on kind of the MISI concept, right? The mutually exclusive or completely exhaustive. And if you take that concept, it's hard for things to fall through the cracks. So if you say the aspirational personas actually match 80% of all the different personas, you're still going to have a 20% gap there. And if those aren't defined, you're going to need to give them a name and kind of get them defined. So hopefully that answers the question as to how we go about it. But it's not a one and done thing. It's a very iterative process, and that's why I don't know if you noticed, but on this slide here, these red things actually say deprecated, which means we got it wrong. So we're getting rid of those, and they'll be replaced, or they have been replaced by something better.